Hello, I'm Anawultus, and today I'm going to tell you that you don't need to overcome the gravitational binding energy of a planet in order to destroy the planet. So, of course, that really depends on how you define what a planet is and how you define the gravitational binding energy. But essentially, what happens with gravitational binding energy is that's the energy, the minimum amount of energy that you need to overcome the gravitationally bound state of that object, in this case being a planet. So a bound state is a state wherein particles have a tendency to remain localized, that is to say, in one area. Now, it is, in this case of gravity, interactional, where each particle has its own, of course, there's different quantum theories about this, its own gravitational field, and by the interaction of them all, they form together into one larger whole, in this case, a planet. Now, I will say that an example of overcoming this bound state would be, for example, reaching escape velocity in a form of kinetic energy where an object on the planet moves fast enough to overcome its bound state with the planet and therefore leave the planet, which is a form of overcoming that bound state. Now, when it actually concerns destroying a planet, I would like to point out that in the case that I mentioned regarding an object reaching escape velocity, it is also possible to physically directly unlink objects without necessarily overcoming their gravitational attraction. And one example would be, let's say, throwing anything in the air, any object, by human strength, just throw something into the air, and you'll see that it goes up, and it's left the ground, it's left your hand, and then it comes back down. And that's because it's still in a bound state, and it hasn't fully overcome that state. And as such, it means that it can physically detach, but then return to a physical attachment. Now, of course, I understand that there's also the atmosphere and other factors at play here. But I will say that that is a small scale experiment that you can do of something much larger. And what would be larger than, of course, the planet in itself? So when it concerns the planet, I would say that you could potentially break the planet into a million pieces that are distinct and separate, and I would think that you'd be hard-pressed to find someone to say that that's not the destruction of a planet. And then what can happen is that because the gravitational binding energy has not been reached, at least in a majority of the pieces probably, they will simply come back together to sort of form a janky planet. However, in the meantime, between the destruction and the reformation, you technically don't have a unified planet, as one would typically consider one to be. So in that time period, I would say it would be fair to say that the planet is destroyed. Now, I understand that there are some individuals that will only consider it to be a full destruction if the pieces are all flung apart and do not recongregate, as you could say. And I would also say in response that there are some people that would consider anything short of annihilation to not be destruction. So what I'm saying is that there's indeed a scale of destruction and destructibility, and there are different definitions that are being used. And my definition, when I say destroy a planet, what I mean is that the planet is put into multiple pieces at least. And if it reforms later, then it still is considered to have had a destruction event in its past. Now, I would say that this is somewhat similar to shattering a glass and then sweeping all the pieces into a pile. What you have is you once had a glass, but now you've got a broken glass, and even if you pile up all the pieces, it's still a broken glass. It's just all back together. And I would say the same is true for the planet. And just like you can throw an object up into the air and it comes back down, what you've done is essentially you've broken the planet into millions of pieces and thrown them all out, and they just come back together because they are still in a gravitationally bound state, which they have not overcome by their kinetic energy, which is why they come back together. So tell me what you think. Do you agree? Do you disagree? Am I abusing the terminology of a bound state? Does it count as breaking a bound state if it's only a sort of temporary break in leaving, in which case I would be wrong, and then gravitational binding energy would indeed be something that would be overcome. But if that were true, then it would be overcome on a much more regular basis than I assume individuals would say. So I do believe that I am looking at the science correctly, but if I am looking at it incorrectly, I would be happy to hear exactly how I got it wrong, and that would make me very happy. So tell me what you thought on that concerning power scaling and other things. If you'd like to contact me, have a discussion with me, I would be happy to do so. Thank you all for watching, and I'll be seeing you all next time on Awultus. Over and out.